Let us start. Hello all, welcome to tutorial session 12 on the course Structural Analysis. Today, we will quickly have a brief overview of week 12 lecture, which are related to matrix methods of structural analysis. And after that, we will solve some problems related to DSM. DSM stands for Direct Stiffness Method. Direct Stiffness Method, which is a form of matrix method of structural analysis. So, I am welcoming you all again to the session 12. So, before solving some problem, we should know how to write a stiffness matrix. So matrix, when we are writing, it will contain some m cross n elements arranged within m rows and n columns, respectively. So these elements of stiffness matrix for structural analysis has some meaning. That in the previous class, we discussed what is stiffness. Stiffness means when you are applying a unit displacement to the structure, then at that point, how much force you need to give, that is called as stiffness of the structure. So we can describe stiffness as force or moment required to cause unit displacement. So now we are giving unit displacement, but since our displacements are unknown, so we are removing that displacement and assuming that displacement to be unit. After providing unit displacement, to ensure that unit displacement has occurred at that point or that joint, you need to apply some external force or moment. That quantity, what you are getting to cause that unit displacement, that force or moment will go into all those elements. And these elements are nothing but stiffness coefficients. And then what will be the unknowns related to it? The unknowns related will be displacements. Because you are taking displacements are as units, are unity. But at that joint, it need not be unity. That the rotation might be some 0.3 radian, 2 radian, who knows? It should not be 1 unit or 1 radian. It might be something, means I am not telling it cannot be 1 radian. It can be 1 radian for some loading condition, but not all the time. So for simplicity, we are assuming our displacement to be unity. To cause that unit displacement, we need some force or movement. Those force or movement corresponding to different coordinates, we will see what are coordinates and how they are given. Corresponding to all those coordinates, you need to fill this matrix, which is called a stiffness matrix. And all those components of those stiffness matrix are given as Kij, where K represents stiffness. It can be axial stiffness, it can be bending stiffness, depending upon the type of members we are taking care. So, coming to the procedure, in writing the stiffness matrix or in ascertaining all those components of those stiffness matrix, those K, I, J, where I and J can take 1, 2, 3 values, means that those are subscripts and those represents coordinates. So first step is to log all those coordinates. Can anyone tell why we are logging all those coordinates? What we will get by logging all those coordinates?
Independent joint displacement.
Independent joint displacement. Okay. When we are reading force method, we are removing all those redundants and we are applying unit load one at a time. Means if there are more than one, if the DSI of the structure is greater than one, then we are removing all those redundant forces. We are allowing the external load to apply to that structure, which is statically determinate as well as stable, due to which we are calculating all those deflections or displacement depending upon the problem. After getting those displacement at those joints or the points under consideration, we are applying one redundant which is unity in nature at a time, removing the external load, and by applying some compatibility condition at that joint, we are writing our equation and solving the unknowns. But in stiffness matrix, what is our unknowns? While we are writing stiffness, we read about displacement method, and I have said stiffness matrix method is a kind of displacement method. So if stiffness matrix method is a kind of displacement method, then what will be the unknowns?
Displacement.
Displacements will be the unknowns. So you have to arrest those displacement. So how you will arrest those displacement? That there in force method, your redundant, you have to remove those redundant because there are additional forces coming that you need to separate it out and put the compatibility condition. Here, the displacements are coming as unknown, which we need to calculate what are their magnitudes. So for doing that, we need to arrest all those displacement. How to arrest all those displacement? Just make the structure stiff. How to make the structure stiff? Remove all those KI. So that is the meaning of locking all those coordinates. If you will remove all those kinematic indeterminacy of the structure, so directly you are making or directly you are locking all those degrees of freedom. That is the meaning of statement 1. Lock all those coordinates or degrees of freedom of the given structure. Second point. Give unit displacement in the direction of coordinate 1 only. Why unit displacement? Why not something else?
To determine the stiffness, as per the definition of stiffness.
Yeah, the very definition of stiffness suggests that if you have unknown displacement and stiffness coefficients you have to write, then you put one unit displacement either in form of translation or in form of rotation. That depends. To cause that unit displacement, how much external work or force you need to apply at that joint, that is called as the stiffness. So to write all those components, you have to provide unit displacement in the direction of the coordinate you removed. You removed means first you logged all the degrees of freedom, then you need to remove, means you have locked all those degrees of freedom. If you have, suppose this is a fixed beam, in this fixed beam they have shown the coordinates are like this. This is 1, this is 2, this is 3, this is 4, this is 5, and let us say this is 6. Now see, if they are asking along 1, you have to provide unit displacement in the direction of coordinate 1 only. This is known as coordinate 1, means that will represent your kinematic indeterminacy of any given joint, and that will be given to you in the problem, and we will see in the subsequent slides how those coordinates will be described. Now if you have to provide unit displacement in the coordinate 1 direction only without hampering the structure, so you have to remodify the structure like this. See, I am just playing with all those support conditions such that our parent structure remains intact and one of our degrees of freedom is only released. Now I have released this coordinate 1 degree of freedom, so I have given a axial release. Now you have to give unit displacement. Suppose you provided unit displacement and it got shrunk by this amount. And this displacement is unity. So to give this unit displacement, how much amount of force you need, that will give you K11 value. And K11 is nothing but the axial stiffness of the given member along the coordinate direction 1. So now, so what will be the value of F? F we all know, A E by L into delta. What is the value of delta? Delta is unity, so A E by L, and that is equal to K11. So this is the meaning of statement 2. Third statement tells calculate the force or movement required at coordinate 1, that is the F value you need to determine, and develop at other nodes. Other nodes means you need to give unit displacement along coordinate direction 1. So what amount of force K11 represent if you have to provide unit displacement? That second subscript defines the displacement along which coordinate. So this will be stated as, if you want to provide unit displacement along coordinate direction 1, then how much amount of force you require to give along that coordinate, that is K11. If I will write K21, then what does it represent? Just speak out, otherwise you won't understand. And this is a difficult topic, I know.
Sir, due to disturbance at 2, means unit displacement at 2. What will be the steep? What will be the force at 1 or K21?
You are telling, you are becoming confused between K21 and K12.
No.
See, K11 represents you want to give unit displacement along coordinate direction 1.
1.
So, for producing unit displacement along coordinate direction 1, how much amount of force you want to give along that coordinate direction is K11. Okay.
Yes, sir.
Is this K11 part clear?
Yes, sir. Yes.
Now come to K21. Listen it carefully because I will ask for other terms.
Okay.
K21 represents the second subscript will tell you in which direction or in which coordinate axis or in which coordinate point or along which coordinate point you want to give unit displacement. That may be in form of rotation or displacement or deflection. So K21 represents if I want to produce unit displacement along coordinate 1, then what amount of force I want to give to the given structure along coordinate 2.
Okay.
Second subscript represents if you give displacement along that coordinate, then what amount of force you need to give to the previous subscript along that coordinate. Means K21 means if I want to produce unit displacement along coordinate 1, then what amount of force or how much force I want to give along coordinate direction 2
2
produce unit displacement along
and
1.
1.
So what will be K12?
K12 is the how much amount of uh, force required to produce unit displacement along 2 in the direction of 1. Means force we need to apply at direction of 1 to produce a unit displacement in the direction of 2.
That is the actual thing.
Means
So
the first subscript is the force, second subscript is the displacement.
K12 means how much force you want to give along direction 1 to produce unit displacement along 2. If you want to produce unit displacement along 2, so you need to give some force along 1. What is that force? That force magnitude will tell you what is K12. So if we have to write for K31, then tell me what will be K31?
Amount of force required to produce a unit displacement in the 1 axis.
Okay. Force
And force will
required.
be force required in the direction of 3. Means 3 what? 3 third coordinate. Displacement or rotation along 1. At 3
So
coordinate.
K31 means force required along coordinate 3 to cause unit displacement along which coordinate?
1,
First.
1, 1.
So this is the underlying statement. So we can generalize it in this format. If Kij is one of the component of the stiffness matrix, then that represents force required along coordinate or joint I due to unit displacement along
Coordinate J.
coordinate J. So I hope this third point is clear.
Yes, sir. Yes.
Now you have to arrange all those values of step 3 in first column of the stiffness matrix. So now tell me K11, K12, K13, K14. I am writing a 4 cross 4 stiffness matrix.
Matrix.
If stiffness matrix is of the order 4, then what is the Ki of the structure?
Ki of the structure is 4.
Ki of the structure is 4. Now you are able to correlate now how the things are getting added up from week 6 onwards.
Yeah, you told me, means you told in the force method the same concept. When we have constructed the force matrix.
Yeah, the same method. When you are writing some equation, means suppose that D matrix is due to the external load, F is the flexibility matrix, and X is the unknown. What will be the unknown in the flexibility matrix? And that will be some 0. And that this part will come from compatibility. If there will be some support settlement, there might be some value. Otherwise, it is 0. And these are applied at given nodes. At certain nodes only, you can apply that compatibility condition, and this X is what are unknowns?
Forces.
Sir, forces in force method. In the same way, you can write stiffness method. And in today's class, we are writing this. We are just substituting it by K, and we will see how this K matrix can be assembled, grouped together to form a global stiffness matrix for a given structure, and how all those unknowns can be determined after forming all those equations in algebraic matrix algebra format, that is matrix method of analysis. Now, arrange all those values in step 3 in first column of the stiffness matrix. So first column is this one. Now see, K11 represents if you want to give unit displacement along 1, then what amount of force you want to give along that direction. So if you have to fill the first column, then your displacement direction is fixed. You have to get that unit displacement along that direction only. But to obtain that unit displacement, you need to calculate the forces along all those joints or coordinates available. All those KIs of the structure, you have to calculate the force due to unit displacement along your direction or coordinate 1. So this is the description of step 4. Now, repeat step 2 to step 4 for all other columns of the matrix. So, similarly, 2, 3, 4 represents, you have to give unit displacement along coordinate 2, and you have to ascertain all those forces of
in the direction
KI values along different coordinates to produce that unit displacement along that coordinate 2. Similarly, third one is unit displacement along coordinate
3,
and you need to ascertain forces for all other coordinates.
1, 3, 1, 2, 3, 4 direction.
Yeah, next. So I hope all those procedures are clear.
Yeah.
So
now
let
the
us,
value.
Let us first derive stiffness matrix for a beam element. So there is a beam element like this, and they have given this is node 1, this is node 2. Let us give it some other, or let it be like this. At node 1, this is your first coordinate, this is your second coordinate, and this way is your third coordinate. One thing you should remember here, that whatever sign convention we have learned in previous classes or in other previous methods, while you are writing matrix or components of a matrix, either flexibility matrix or stiffness matrix, you just forget whatever sign convention you that are present in your mind. You just have to concentrate in which way they have given you the coordinate direction. Means now someone can argue that here the coordinate 3 is in anti-clockwise direction, but in general we take clockwise direction positive. So someone may argue while writing the component, that component only, there will be a misconception between plus and minus. So you just forget whatever sign convention you know, whatever they have given, assume that direction to be positive. If your movement or your forces are coming along that coordinate direction, it's okay, take it positive. Otherwise negative. Okay, let this be 4, 5, and let this be 6. Now tell me, step 1, what they have said, to completely log the structure. Tell me, what is the Ki of this log structure, this fixed beam?
Ki is 3.
Ki is 3.
0.
So the underlying definition of log structure is that you have to make a structure such that the Ki is vanished. If you are arresting all your Ki's, then obviously your log structure will have
Ki 0.
Now, how many coordinates they have?
Coordinate.
These are the coordinates 1, 2, 3, 4, 5, 6. So how many coordinates they have?
6.
6. So what will be the means stiffness matrix dimension?
Cross second level পাগল হয়ে যাবে।
So this is our entire
Beautiful matrix.
stiffness matrix. So if you want to find K11, then how you have to modify your log structure? Tell me. Tell me. The K11 means what? In which direction you find displacement?
Displacement at 1, while we need to apply force along 1.
So you have to release axially so that it can move in this direction, and you want delta to be 1.
1.
Correct? So for this, how much force you need here?
F, which is unknown.
Which is unknown means you know na? Delta equal to PL by AE.
AE upon L.
Delta is 1. So what will be P or what will be F? AE by L, that is stiffness, and that will be K11.
Yes,
Correct?
sir, yes.
Now, to determine K21, the structure will be this, but now you have to find if you need any force along this coordinate to have delta equal to 1 along 1. So what will be your K21 value?
0.
0. Tell me K31.
A31. 0.
K41.
Suppose 0. All will be 0. 4, 1, 5, 1.
So we got first column. You need now second column. So to release your degrees of freedom along coordinate 2, what type of joint you need to provide?
Vertical shear hinge.
That will be shear release.
Vertical.
Now you need unit displacement like this. So the beam will try to take this type of deformed shape, and here this will be unity.
CI del upon L square.
Now you tell me What will be K22 first?
6EI upon L square.
6EI upon L square. How come you got 6EI upon L square?
Because from that fixed end moment equation.
So just write, don't tell it like that. Here one movement will come. Here one movement will come. So will be 6EI delta by L square,
Yes,
where
sir.
delta is 1. 6EI delta by L square. Here delta is 1. We will neglect while we are writing this K2, Kij components. Okay. This 6EI delta by L square is trying to rotate the beam in which direction? Anticlockwise?
Yes, sir.
So, to prevent that, a clockwise couple is required such that
Yes,
it
sir.
will come into stability or static
Yes, sir.
equilibrium.
Yes, sir.
So,
Yes, sir.
what much means what will be the value of these forces?
M upon L, 6EI del L square upon L.
Means 6A delta upon L cube you are telling.
No. Carry over. 9.
I am getting this.
How you get this, sir?
See here. Yesterday we did questions like this. See my pen. Can you see my pen?
Yes, sir. Yes.
Here is a moment 6A delta by L square.
Yes, sir.
Here also there is a movement 6A delta by L square. Okay.
Yes, sir.
So overall the pen will try to move in means anti-clockwise manner.
Yes, sir.
So
MAV plus MBA
overall
upon L.
how much net means movement is there which is not balanced. 12EI delta by L square.
12EI delta by L square.
So that much amount needs to be balanced by these
Yes,
two
sir.
couples, two forces creating a couple separated by the span length.
Yes, sir. Yes, sir.
So 6EI delta upon L square plus 6EI delta upon L square, that becomes 12EI delta upon L square. That is the unknown, not unknown, that is the net
Total movement.
disturbing movement or force acting on this span. This will be
Yes, sir.
overcome by the couple. That couple you will get by a what? Divided by span length if you will do,
Span
you
length.
will get the forces which will try
Yes,
to
sir.
resist that unbalanced
Four.
movement. Now
Yes, sir.
can
You
you
will
tell
read
me
for
what will be
KMK.
K12? I am writing, just see. What will be K23? You tell me.
0.
Sorry, K32. We are writing for second column, na K32. Tell me.
0, sir. 0.
0. K32 will be 0.
3, 2. Now 6 I del by L square. Sorry.
42
420
52
6 EI del by L square.
52, that is 62.
Uh,
Now tell me why I have written minus. Why not plus? Tell me why minus.
uh, because we have
What is
assumed
your
the
coordinate? What is your
pipe
coordinate?
is in upward and 12 EI del Q is downward.
Correct. So
I know.
what I said just before starting this slide, remove whatever you know about the sign convention while you are writing the matrix. Just follow whatever in which direction they have taken the coordinates. If your forces are coming in that direction, it will be positive. If it will be vice versa, it will be negative.
Negative.
Okay. Now,
Yes, sir. It's a application based method. Means all of the concepts are now getting used.
it will be. That is the reason those things are slightly on the higher side. It's
Sir,
not
application just
structural analysis, it's a application and advanced structural analysis. Now we have to write this third column. Third column means you have to give unit rotation. Now tell me, if you have to release the rotation, then how your beam will look like? What will be the
hinge,
condition?
hinge or roller.
Okay. Now, here theta 1 is 1. So, now tell me, due to if you want to create that unit rotation, how much movement you want to apply here? Yesterday only we derived 4EI. Tell me, are you there? 4EI upon L. So what will be the carryover? It will be 2EI upon L. Two EI upon L. This 4EI upon L and 2EI upon L is trying to rotate the beam in anti-clockwise manner. So to keep it in static equilibrium, you will get two reactions. It will be 6EI upon L square. 6EI upon L square. Now can you tell me what will be K13? K23?
Sir, I'm getting
Now tell me what will be K23?
Sir, are you getting?
Hello?
Hello.
Yeah.
Hello, sir.
Your voice is not clear. Hello?
I'm unable to see your screen.
Uh, just log out and log in again. I think there is a network issue from your side. It's getting recorded from my side. There is
Yes, now I am getting.
now your voice is also clear. Now tell me what will be K23?
CI upon L square.
How much?
CI upon L square.
K43? K53?
Minus CI.
K63?
4EI upon L.
From where you are
2
getting
EI upon
4
L.
EI? Now your third row is done. Now for creating or for calculating all those fourth row components, fourth column components, you have to give for fourth column. You have to give unit displacement along fourth direction. Now, it is getting expanded by delta amount. So from here, it is moving to this position. So this delta is 1. This delta value is 1. So if you have to write K14, it will be 0. K24, it will be 0. K34, it will be 0. K44 will be AE by L. K54 will be 0. K64 will be 0. Now, for fifth column. For fifth column, if you have to write, now it will be like this, and it will move upward by unit displacement delta equal to 1. So now this is moving like this, so you will get movements in anti-clockwise manner, and this will be 6ci upon L square. This will be 6ci upon L square. If these are 6ci upon L square anti-clockwise, then two forces will come. It will be 12ei delta upon Q. This will be also 12ei delta upon LQ. Now write K15, 0, K25. What will be 25 value? K35, K45, 0, K55 will be minus 12ei upon LQ. K65 will be how much? 6 EI upon L square. Now for sixth column. For sixth column, you have to give unit rotation along coordinate 6. If you are giving so this will be 4 EI upon L. This will be 2 EI upon L. These are making a anti-clockwise rotation to the beam. So this will be 6 EI upon L square. 6 EI upon L square. So you can write K 16 will be 0. K 26 will be, how much K 26 will be? K 36 will be 2 EI upon L. K 46 will be 0. K 56 will be minus 6 EI upon L square. K 66 will be 4. It is in the same direction, 4 EI
4
upon
EI.
L. Now everything is done.
Yes, sir.
We
Yes.
just have to take it into matrix form.
Sir, in middle, sometimes I unable to see your screen. I think the issue is from because now it's visible.
Now that might be due to your internet is not stable, I guess, because there is no issue from my side. I can see that it is showing our screen sharing is going on and green signal is there. And at
Okay.
times your voice is also not clear. That might be the reason that your internet connection might be somewhat unstable. Okay.
Okay, sir. Okay. Now it's clear, I guess.
Okay, you just let me know when you are facing issue.
Yeah, sir. Yes, yes.
So K11 is A by
L
L and rest are
0. All are 0. তারপরে 0
K21 is
ଗୋଟେ 6 বড় কথা 12 EI
K21 is
upon L
also 0. K12 is also 0. K13, where is K13?
0
K13 is also 0. K14 is also 0.
0
K15 is also 0. Everything is 0.
0
2, 3, 4. 1, 2, 3, 4, 5, 6. 0, 3, 4, 5, 6. Now K22 is
12 EI
12 VI by L cube.
cube
K33 is
6 EI
4 EI by L. K33. First write the diagonal,
diagonal.
principal diagonal elements.
Okay.
K44 is A by L. K55 is
12 EI upon L
minus 12 VI by L.
minus
K66 is
4 EI L
where we have written that 4
in
EI.
corner.
Now K23 is 6ei by L square. K32,
That will be same symmetric.
now it is coming or not?
Yes, sir. Yes. P.
That are the conclusion we have to make from here, as if we don't know anything. K24 is 0. K42 is K42. Where is K42 is also 0. K25. K52. 25, 12, 52. 25 is 12 by L cube. How come 52 is coming minus 12 by 52 is minus 12 vi by L cube. So 25 is you are applying unit. This will be minus 12, na? 25.
Which one? 25.
Sorry, not minus 12. It should not be minus 12. It should be plus 12 only. Okay, let us try forward. K26. What we are getting for K26? 6ei by L square. K62. What we are getting for K62? 6ei upon L square. This we will see after we are complete with every part. K34.
3, 4, 0.
34 is also 0. 43 is also
4,
0.
3, 0.
K35. 35 is 6ei by L square. K53.
5, 3.
Minus 6ei upon L square. 3553.
6 ei upon L square.
This is also some issue is there. Okay.
The minus S.
Now K36. What is K36 value? 2ei by L. K63. 63.
2 ei upon L.
K. It will be 4, 5, 4, 5, 4, 6. Yeah, 4, 5.
0.
4, 5 is 0. 5, 4 is also 0.
0.
K64. 0,
0.
4, 6.
4, 6 should be 0.
Nah, it is there, right?
4, 6.
Yeah, it is 0. K56. What is the value of 56?
Minus 4 ei upon L square.
65.
5 plus 4 ei upon L square.
K56 is coming here minus 6ei by L square and K65 is 6ei upon L square. Okay. So this should be symmetric, but why we are getting some values symmetric and some not symmetric? Let us check from K25. 2, 5. 2, 5 means we have applied along 5 direction. We are getting this. There is a huge blunder we are doing and still you are not telling.
Minus.
अरे यार. And my pen is also not working.
That is downward.
So give me some time because my pen is not working. Okay. 2 minutes. 2 minutes.
Okay, sir. Okay. Okay.
Okay, I am just cutting it here because the eraser is not working. Okay. Now check
Okay, sir.
this. When you are giving a unit lift along 5 coordinate, the beam is taking this kind of shape here. So if it is trying to rotate clockwise, so the fixed end movements will come. It is trying to rotate anti-clockwise, so fixed end
Anti-clockwise and fixed end moment will come
clockwise.
clockwise.
So this will be this way and this will be this way.
This
So
way.
if this comes like this, then your K 3 height will be minus because
Minus.
it is against our third
Sign
coordinate.
convention.
So it will be -6. Same here also it will be -6. So -6, -6. Now check this 6 ci upon L square and 6 ci upon L square is trying to rotate it clockwise manner.
Clockwise
So
direction.
those couple will come in anti-clockwise manner.
Anti-clockwise direction.
So this will be 12a upon L square downward.
And it is upward.
Now you have to state it here plus, but while writing you have to write it minus because it is against your coordinate direction. This will be 12a delta by L cube downward and this will be 12a delta by L cube upward. Then delta is 1. So downward means here it will be minus because it is against your second coordinate system. It is pointing against your second coordinate and this will be plus. Now check K3 and K53 are same. Minus 6a delta by L square.
Minus 6.
K25 and K52.
2, 5.
Yeah. Now it is.
EI upon L square. How Royla?
K65. K65 is minus 6ci by L square. K56 is also minus 6ci by L square. So what are the major conclusions we can make? Tell me. This stiffness matrix will always be
Symmetric.
Square and symmetric. So we did some mistake, and how we again overcome the mistake you also got. Means anyhow we did it mistakenly, not by some intention. If at all you did some mistake, then you can also check, because those matrices are always symmetric in nature. And symmetric about which diagonal? Principal diagonal. So this is the most generalized stiffness matrix we can get in this chapter. Okay.
Yes, sir.
Now let us solve some problems. Now tell me for this question, what will be the option? You should say for should not. They are asking should not. This not should be taken care of. Okay. Which one?
3 and 5.
3 and 5. Which redundant reaction? Let me read the question. Which redundant reaction or forces should not be removed to make the structure statically determined? Okay, you are telling if we will remove 3 and if we will remove 5, then what will happen? Your structure won't be statically determined. Okay, let us remove 3. If 3 will be removed, there will be nothing left. If 3 will be removed, there will be nothing left. If 5 will be removed, then horizontal reaction is removed, so it will be like this. So is it not statically determined? It is stable also. It is stable, simply supported beam. So option D can't be the option.
Which redundant reaction forces should not
See, they are asking remove 2 of those redundant in such a manner that when you will get your primary structure, the primary structure won't be statically, means it cannot be taken as a statically determinate structure because it will be unstable in nature. So you have to select a combination that 1, 2, 1, 3, 1, 5 and 3, 5, out of which
then option
3, 5 is eliminated. So you are left with A, B, C option. So out of those 3 options, there is one option in which way, if you will remove 2 of those redundant or if you will erase 2 of those redundant, then your structure might be statically determinate, but that can't be used as 2 of the redundants because that primary structure won't be stable.
1 and 5, then C option.
Yeah, correct. If you will remove 1 here, then you will get roller here. If you remove 5 here, you will get roller here. And if 3 rollers are present consecutively, then 3 parallel reactions will come. And if someone provides you some inclined loading here, inclined loading or horizontal load, then it will go on moving without any
And
static equilibrium, because static equilibrium won't be valid there. So option C is the correct.
correct answer.
Now, you have to form a stiffness matrix for the given coordinate system 1, 2, 3 of the following beam and write their stiffness matrix. So can you help me?
Yes, sir. Yes.
Now tell me how to do this. First step. Step 1, tell me.
Lock all the coordinates.
If you lock, you will get what kind of structure?
Fixed beam.
This is step 1. Next step. But to which coordinate can we remove first? Let us
1,
do in ascending order only. First 1, then 2, then 3. Okay.
3. Okay.
Then first remove 1. So how your structure will look like?
1 fixed and 1 wound horizontal rollers.
That is now you have to give 1 unit displacement here. So what force you need? Correct? Now
Yes.
tell me K11 will be K21 will be K31 will be. Now remove 2. Here you have to provide 1 unit lift. So how your, we have done mistake here only there.
Last
6 EI by L square.
L square.
6 EI by L square.
L
So
square.
6 EI by L square, 6 EI by L square are clockwise. So there
Clockwise.
will
So
be
we need anti-clockwise.
anti-clockwise couple. 12 EI by.
Clockwise. L cube.
Now tell me K12, K22, K32. Tell me K12 will be, K22 will be
minus 12 EI.
K32
6 EI minus 6 EI upon L square.
So K22 will be positive. Why? Because your second coordinate and the reaction coming both are along same orientation. Or so what will be the sign convention?
Plus. In a minus. I got.
Now remove. What to remove?
3. The coordinate 3.
So here roller will come.
Hinge.
Hinge or roller, anything. And provide unit
Clockwise.
rotation. So here it will be
4 EI upon L.
how much carryover it will give?
2 EI upon L.
This 4 EI and 6 EI upon 2 EI upon L will give a net 6EI upon L anti-clockwise movement.
Anti-clockwise rotation plus.
So to arrest that anti-clockwise, how much clockwise movement you need?
With
6EI by L. How you can provide?
Upon
Just
L.
give a couple. Okay. Couple will be.
Yes, sir. Yes.
6EI upon
6 L square.
Correct. Can you write K13?
Yes, sir.
K23.
0.
K23 will be minus.
Minus 6EI.
K33.
Minus 4EI.
So which option? Just write first your values, then match. A by L 0, 0, 0, 0.
0. Then 0 to L EI upon L cube.
Wait. Little bit. Everything is clearly visible, right? In my screen.
Yes, sir. Yes.
Okay.
Yes, sir. Yes.
So which option is correct? Option
A.
So now do you have any doubts?
No, sir. No.
How eraser working? Now tell me, this is a theoretical question. There is no need of describing this because I have told it during the procedure time.
Use the correct option to generate the highest column of the statement of a member in the structure.
Let us read the question.
Option D.
You
Option
need
D.
time.
No, sir. Option D. Answer.
Option D.
D.
Sir, I am unable to hear you. Can you speak out loud?
Option D.
This
D
one,
for
correct?
dog.
D.
Yes, sir. Yes, sir. D.
Okay, let me read. To generate the ith column of a stiffness matrix of a member, ith column of a stiffness matrix of a member, okay. So you are telling, you are calculating displacements in stiffness matrix by applying
Sorry.
unit displacements.
Sorry.
This is a too absurd option. Displacement, how you will calculate your unknown by applying unit unknown? Means unit unknown means wherever what method you are assuming, you are taking those unknowns to be unit and you are calculating the other counterpart. That may be force or displacement. But you cannot calculate your unknown applying unit load or unit. If you're using force method, you cannot calculate force by applying unit. Similarly, if you are applying displacement method, you cannot calculate displacement by taking unit displacement. So option D is ruled out. Now tell me, you are having three options.
Okay.
Which one?
Option A, sir.
Option A. Let me read. Force in all the coordinates are calculated after applying unit displacement at coordinate I with zero displacement at all other coordinates. Okay, this can be option. Let me read B and C also. Displacement in all coordinates are calculated by applying unit force. That is a force method, not a stiffness method. Force in all, or that is that we do during flexibility matrix method, not in stiffness matrix method. Force in all the coordinates are calculated are applying unit force. Forces are calculated by applying unit force. So C and D are all redundant statements. So option A is the correct option. Okay.
In first, I hurriedly go to the option B. I have my bad.
Okay. Okay. So here answer is option A.
Option A. Okay.
Now, read the question. Consider the following beam and solve the question 8 to 10. 8 to 10 means this is question number 8. They are telling this is question number 9 and this is question number 10. Means this is a linked or passage type question. We are having 3 bits. Here a movement is applied at point C, which is external, of 20 kilonewton, and support B is settling by 2 mm downward. Given that modulus of elasticity or E value, Young's modulus, is given as 100 GPa. Moment of inertia is 10 power minus 7 meter power 4. Find out the correct stiffness matrix of the member AB, assuming that degrees of freedom are in ascending order when writing stiffness matrix. Can you do it? Huh? Tell me the approach. After that, solving won't be a problem. You have a beam. This is a continuous beam. But you have to write the stiffness metric for each span separately. So let this be first one. Let this be second one. So first you have to write the stiffness matrix for first beam AB. Next you have to write for stiffness matrix for BC. So for AB, if you want to write, first what you have to make? You have to make, what you have to make?
Lock all the coordinates, then apply individual.
Now, there are 4, 1, 2, 3, 4 coordinates. 4. So we have to release one at a time. So if you want to first release one, and this they are writing, the coordinates are arranged in ascending order only. 1, 2, 3, 4. No, I should not write it here 1, 2, 3, 4 because this is the global matrices they have given. You can write it here 1, 2, 3, 4 because find out the correct stiffness matrix for a given member they are telling.
AB.
So this will be 1, 2, 3, 4 only. This will also be 1, 2, 3. Okay. Now remove one, that is release one, and give unit displacement along that direction. Okay.
Yes, sir. Yes.
Now if you will give unit displacement,
Horizontal release. Sorry, vertical release. 1.
So this will be 6ci by L square. This will be 6ci by L square. 6ci by L square, 6ci by L square. We'll try to rotate it anti-clockwise.
Anti-clockwise.
So a
It is
clockwise
clockwise.
couple.
12 EI.
12 EI upon LQ and 12 EI upon LQ. Now, once you have removed one, then you will get K11. K11 will be how much?
12 EI upon LQ.
K21 will be
6 EI minus 6 EI upon L square.
minus or plus.
No,
My
plus.
intention is to write
Yeah.
plus only. I won't change to minus.
No. The sign is given. Anti-clockwise. 3 1. Minus 4 1 plus 5 1 9. 5
Check
1.
if you are getting this or not.
5 1 minus.
You are getting this, right?
Yes, sir.
How come 5-1 came?
No.
Now, fix all those again. Remove and apply displacement along coordinate 2. Unit displacement. That will be unit rotation. So, if you have to provide unit rotation, then like this. Now, tell me. 4 EI by L.
4 EI.
This will
2
be
EI. 2
reactions.
EI upon L.
Reactions. How much reaction it will give?
6 EI. 6 EI square.
Now, tell me K 1 2 will be
Minus 6 EI.
minus or plus?
1 2 plus 6 EI.
Plus 6 EI by L. K12, K22. What will be K22? K32. K42. What will be K42?
Plus 2 EI upon L plus.
If you want to, now third is remove 3 and give unit displacement along coordinate 3.
3.
This is unity. Now, if it is going upward, then movements will come like this. 6 ci by delta by L square. This will be 6 ci delta by L square. Those are making it net clockwise movement is acting. So you have to provide anti-clockwise couple.
Counterclockwise.
12 EI by
L2.
12 EI by L cube.
Okay.
Now K
3
13 will be how much?
minus
K
by
23
cube.
will be how much? K 33 will be how much?
Minus এটা plus of 12 here.
K 43 will be how much?
Minus 6ai
Now,
6ai upon L square.
now I am writing or remove 4 and apply unit rotation along 4. So if you have to remove 4 and apply unit rotation, it will be like this. Now this will be 4ei by L. This will
L
be 2ei upon
counterclockwise. L we need clockwise couple.
So this will be 6ei upon.
3i upon L square.
Now tell me, K14 will be
2ei 3i upon L square. 4 4 4ei 4ei upon L
4ei upon L.
yes sir.
Now, can you write the matrix for member
AB
AB? E value given, I value is also given, right?
but it's kept constant
Okay.
outside.
So let us write it first, then we'll. Otherwise, what can be done? Okay, let us keep EI common from first only.
Sir, one thing it's given settlement 2 mm.
Huh. That settlement
Down one.
won't come as of now. Na? That settlement is the known value you know.
Okay, okay,
Displacements
okay.
are unknowns, right?
Okay, okay, I got.
So in
Uh-huh.
which matrix you have to put it? Here I said, na?
Uh,
Here. Unknown.
uh,
So some unknowns you know or deliberately they have given to complicate the question, but that is not for complicacy, that is making your task easier.
okay, sir, okay, okay.
Tell me now, K11 will be 12 by L cube. K14 is 6 by L square. K, tell me, otherwise I have to, K21 is 6 by L square. K31 will be minus 12 by L square, L cube. And this will also be 6 by L square. So 6 by L square, 12 by L cube. Four by L, 12 by L cube. Minus 6 by L square, 2 by L,
Minus.
minus 6 by L square, 2 by L, minus 6 by L square. Here, how much will come? K34 minus 6 by L square. Now just put the L values.
L
12,
values
12 by 4Q. 4 na length is. This is L value.
4
4Q. So 0.1875. 6 by L square will be
1
0.37.
upon 1 upon
So you got 0.375, it will be here, minus 0.1875 will be here, 0.375 will be here, 2 by 4 will be 0.5, minus 6 by L square will be minus 0.375, 4 by L
1
1, and here 12 by L cube is
point 1875 minus 0.370. Point 375 0.1.
So which option? Oh, option B I am getting. Are you getting any other option or option B?
No, sir. Option B.
Option B, right?
Yes, sir. Yes.
Options. Option B only is the correct option. Okay. So we found out the for member AB.
AB span.
So now the absolute
Absolute
vertical
vertical.
reaction force VB at support B of the beam. So to determine VB, you need to calculate the global stiffness matrix. Okay. So how to calculate the global stiffness matrix? You have to again write the stiffness matrix for span BC. So can you write for span BC? Hmm?
Yes, sir.
Just write and tell me then. You have the figure, na?
Okay.
You write and tell me. Tell me what you got for K33.
AE upon 2. AE upon 29. 12 EI
Upon 12 VI upon You got or not?
Yes, sir. Yes.
You got some portion or not?
Yes, sir. I got all.
Then tell me why you are stopping. It will
I'm
make my
writing.
work easier.
I'm writing. ODI, ML, tutorial. Okay. API upon a square.
Now, These are attached to coordinates 1, 2, 3, 4. This, when you are writing K, B, C.
Sir, why you have written divided by? Oh, no, 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 no.
Here, EI by 2 is there.
Yeah, sir. Yeah, I got it.
So here the coordinates will be 3, 4, 5, 6. 3, 4, 5, 6. So now the values I am writing directly will be 0.75, 0.75 minus 0.75 and 0.75, 0.75 minus 0.75 to 1.75, 1 minus 0.75 minus 0.75, 0.5,
EI 3 by 4, 3 by 16.
Now you got KAB and KBC. You have to assemble it. How many degrees means how many coordinate system you have in total? 6. So your global coordinate is your global stiffness matrix will be of the order. What will be the order?
4,
4.
6 cross 6.
6
Global.
cross global. Now we have to write. Now I am writing first again KAB here and KBC here, so that we can write it easily. You have written it, just tell me the values again. This was 0.18.
7.5.
Next one.
E7.
Next one.
3.75.
Third one. K13. This will be minus, right? You just take it down and tell me, because coming back and writing there will be a difficult task otherwise. Have you noted?
Okay, sir. Okay.
You
Yeah.
note it down and just go on telling me when I ask.
Okay. ABA. 0.18 मैं औधा लिखती हूँ.
Written.
Wait a minute, sir. 1 9. Yes, sir. Yes, done.
Now when I ask, you just tell me. Write
Yes,
this
sir.
matrix also. Write this matrix also. KBC matrix.
Value 0.75. Sir, how you have calculated so fast?
I
Means
have the value. I have the
okay,
values.
okay. Five. No, sir, it. I have not divided that EI by 2. That's why I got everything just double.
Hmm.
Yes, sir, now it's done.
Done, right? Now tell me. 0.375 K22 value will be for
Minus
AB. This value 1.
1.
Next one K2 23.
Minus point 0.375.
K24
0.5. Sir, 0.5.
0.5. So here also it will be minus 0.375 minus 0.5. These both are 0.1875. One will be minus, na?
Which one? 3. Yes, sir, yes, 3.
Next, tell me 3334. K33 K34.
Point 1.
Tell me.
T3. 0.1875. Plus.
Then
Minus 0.375. 34. 4 is 1.
KBC, tell me again.
BC is 0.75. Then again 0.75 plus minus 0.75 plus 0.75 plus 0.75 minus 0.75 plus 0.75 1 minus 0.75 0.5 0.5 0.75 1 minus 0.75 minus 0.75 minus 0.7. Yeah.
These see now these are associated to coordinate 1, 2, 3, and 4. And these are associated to coordinate 3, 4,
4,
5, and 6.
6.
Now you have to club them to get the global matrix. So let us write the global matrix, which will be of the order of 6 cross 6. One will be same. 1, 2 will be same. 1, 3 will be. First I am writing this matrix, KAB matrix, directly in their places. Okay. Now you check. This is K33 and already at K33 from KAB something is coming and that node coordinate 3 is common between those two beams or two spans. That is the reason we are getting two values which will be clubbed together. Means this will be 0.75, K34 will be plus 0.75 again. This will be minus 0.75 alone and this will be 0.75. Here one. This will be again 0.75 plus 1 minus 0.75 and 0.5. Here it will be minus 0.75 minus 0.75, 0.75 minus 0.7. 0.75, 0.51 minus 0.75. And what about these entities? Those are 0. Now you got?
No.
What you do? What you are not getting?
Means in the 3-4 column.
P4.
3, 4, 4, 4. No. You just add, right?
That needs to be added because see, this coordinate 3 and 4 are shared between this part also and this part also.
This part also.
So when you are assuming that when you are releasing this coordinate 3 and giving unit displacement, both beam will get hampered. But since we are doing it part by part, so we are not considering when we are giving unit displacement, while considering AB, we are telling that BC part is not hampered. Anyway, BC, there is no displacement. But again, when we are considering that 3 node or 3 coordinate, for BC, we are telling that B coordinate or B joint of AB is not hampered. So anyhow, both are getting hampered due to that displacement of coordinate 3. So combined effect from both the span will come because we are doing it like a superposition. We are not considering second one for the first one. Then we are keeping ideal first one and doing it for second one. So when you will combine it, you will get the overall response of the structure. Correct? Till this point you got or not, tell me. After that we will proceed further. No doubts?
Got, sir.
Now, you got the global stiffness matrix. Now, how your equation will look like? Your F external force will be F fixed end forces plus K times your unknown matrix. Correct. Now you wrote this matrix. Your fixed end forces, this F matrix will be a null matrix or vector. It will not be a matrix, it will be a vector and it will be 0. Because
no fixed end movements. Because no external forces.
No span loading is there. That is the because fixed end movements are generated because of span load. If there is
Yes,
no
sir.
span load, fixed end movement is 0.
0.
So this is 0. You know this K matrix, which is 6 cross 6. Now let us write F matrix. F will be F1, F2, F3, F4, F5, F6. So tell me, F1 is what? Unknown. F2 is 0. F3 is unknown. F4 is unknown. F5 is
5. F5 is unknown.
F6 is
6 unknown.
unknown.
Minus 20. 20 kilonewton per meter.
Now you tell me the U matrix. Those are displacements. That will be U1, U2, U3, U4, U5, U6. You can also write delta 1, delta 2. I am writing delta 1, delta 2, delta 3, delta 4, delta 5, delta 6. This delta does not mean it will be only translational movement. There will be rotation. This delta 2 is not translation. These are rotation because those are attached to rotational degree of freedom.
Yes,
Now
sir.
you tell me, U1 is
Yes.
U2 is U3 is
20
U3 is
mm. Something given 20 mm. That
2 mm downward. So minus 0.002. Why minus? It is downward. But
downward
your
given.
third coordinate is upward. U4 is unknown. U5 is 0. U6 is unknown. Now you got F matrix, you got U matrix, you got K matrix. Correct?
Yes, sir. Yes.
Now what you need to find? See, support reaction at support B and slope at support C. So means you need to find reaction at support B means F3, and slope at support C means U6 or theta 6. We are writing U6. So you need this F3 and this U6. Can you calculate? Can you calculate?
Sir, how to calculate?
How to calculate? F1 you will be there will be some reaction. F3 there will be some reaction. F2 there will be some, there won't be any reaction, so 0. F6 there is given. F4. Tell me what about F4? Will that be 0 or not? Externally, along that coordinate in that joint, is there any external movement?
No.
Like at 6, we are directly writing minus 20 kilonewton meter. But at 4, is there any reaction or
No,
movement?
sir, no. No.
So F4 will be 0.
0.
Where that answer? This will be 0. Now you can from that whole equation you can take out your unknowns, whatever you need. Just I am writing it. Just see 0 F3 0 minus 20,000 Newton meter. I am doing it in Newton meter. Okay, everything that will be equal to K matrix, and 0 is related to F2, so you have to take U2, then F3, then it will here it will come minus 0.002. F4 is 0, so U4 will come. Then you are taking minus 20, so it is corresponding to U6. Now, till this point it is all right.
Yes, sir.
Now you see, when you write a matrix, suppose we have 2x plus 3y equal to 6, 4x plus 3y equal to 90. So how you will write it in matrix format? 2, 3, 4, 3, x, y equal to 6 and 90. You will write like this. So from the whole matrix, we have taken 4 equations out. So corresponding to that, we have to write these coefficients only. Means we have to again extract from the global stiffness matrix which are the coefficients related to these equations, like U2, something multiplied by U2, something multiplied by U3, something multiplied by U4, something multiplied by U6 will be equal to 0. So you have to extract those 4 components now.
Yes, sir, yes.
So when you will extract that, you will get, I have the values, you will get 1 minus 0.375, 0.5 and 0. Next will be minus 0.375, 0.9375, 0.375 and 0.5. So 0.75, it is 0.75. This is 0.5, this is 0, 0.75, this is 0.375, this is 2, this is 0.5, this is 1, and this is 0.5. Now check. This 0 is equal to 1 times U2 plus of minus 0.375 times minus 0.3 into plus 0.5 times U4 plus 0 times U6. So how we are writing this? 1 is here. Your F matrix will consist of F1, F2 and F2 is 0. So 0 will be equal to this 0.375 times U1, 1 times U2 minus 0.375 times U3 plus 0.5 times U4 plus 0 times U5 plus 0 times U6. So, but you have eliminated U1, you have eliminated U1, U5. So, in that way, this 0.375 and 0 you can eliminate or not? You are getting or not?
Yes, sir, yes, sir. You did.
In that way, you have to reduce your size of the
matrix
or dimension of the matrix. Then now you can solve it easily. Can you solve now?
In the form of equation.
You have four unknowns, you have four equations. So you have to solve it now.
Sir, I think that in our semester we used to do in calculator.
This can be done in calculator. That black calculator, you can do it. So
Yes, sir, I
from
have.
here, then
Just
from
I need
here,
to remember the steps.
from here you will get F3 will be equal to minus 1.3755. F3 by EI is minus 1.3755. And we got F3. And D2 or U2 will be minus 0.334. U4 is 0.667 and 2.33 minus 2.332 is U6. So F3 value we are requiring here. F3 value we got minus 1.3755 into EI. So minus 1.3755 into EI. When you multiply, how much you are getting? Just check. Just check. I have given you all those values. Just substitute it and tell me how much you are getting. So we got F3 equal to minus 1.3755 by EI. F3 by EI is this much. So you will get F3 as minus 13.75 kilonewton. Means after you substitute E value and I value and be consistent with the numerical units, you will get F3 as minus 13.75. So option C is the correct one. Now, for theta C, what was the unknown we have taken? U? U?
6.
What we got? Here I have written na U6 minus 2.332.
In the corner.
Yeah.
Yeah.
I should erase it and write it in a good space. What we got? U2 minus 0.334. U4 we got as U6 we got as minus 2.33. And this is 0.66. Okay. So our theta C is U6, which is nothing but minus 2.332 radian. Option C. This is the way how all those matrix analysis is done. I know this will be a time-taking task because all those equations and big formulations will come.
So 1 hour spent.
Yeah. Those are all big and rigorous. If more coordinates you will get, then the how many number of coordinates you will get, that many times your K matrix will increase, the dimension of the K matrix. So think of the computational efficiency. So these types of questions are generally done in finite element method. These are normally for coding purpose. When we are solving some problems, there are n number of matrices and matrix order goes to some n cross n, where n is a very high value. There you cannot do it by manual calculation or hand calculation. There where you have to code your own problem using some any language
Software.
you want, not software, by codes, maybe
Okay, okay.
MATLAB, maybe C, C++, Python. After coding, your unknowns, you can get it from there. Like here, our unknown was F3, F2, F1, this matrix you can get. Or somewhere, like for this F matrix, this F2 you know, this F4 you know, this F6 you know. But corresponding U2, U4, U6 you don't. So some forces you don't know, some corresponding displacement you don't know. So anyhow, when you will write the code, you will get all those force metrics as well as displacement, unknown displacements. Okay.
Right element.
Yes, so that's it from my side for today. So if you have any question, just let me know.
No, sir. No, for today.
Okay. So do you need any summary session from first to
Yes,
last?
yes, definitely. Definitely, definitely. I was about to ask what about the uh,
But
management
in that class, or if you need a summary session in that class, my effort will be less, your effort will be more. Because I will only tell you the topic name. You have to describe what you have studied and what problem you are facing. So once you tell your problem, then I will tell my statement how you can rectify it. In that way, I am planning. If you want that summary, that is an optional session anyhow. If you want that summary session, I can conduct. But the thing is, there are terms and conditions. The thing is, I will write the topic name. You have to describe what you learned from there. And again, you have to tell me what problems you are facing. In that way, it will be like both side interactive session. I won't do it like a single-handed class session kind of thing. I don't want to do
I
it
know,
in that manner.
just give me 6 days.
Sorry?
Sir, I said that just give me 6 days. I will complete.
Now your voice is again not coming good.
Hello.
Yeah.
I told give me 5 or 6 days. Just give me 5 and 6 days so that I could complete.
Anyhow, you have to think of your exam timing, and maybe next week we can do. But that day I won't come prepared. You come prepared and you tell me. That will be summary session. That will be a homework session for you also. Okay.
Okay, sir. Okay.
Okay. Bye.
Thank you.